Okay, so this week's going to be a little bit different. There she is!
No, my dad actually left this morning, so.
Okay, because they actually had you excused, so.
Yeah, because my mom called because my dad's leaving to go pumping in Miller.
Oh, okay.
Go pump manure, so.
Okay.
I
Okay.
sat there and watched all the trucks go by.
Okay, but you're here today, so I'm happy. That's good. Okay, this week's gonna be kind of different because 2.5, 2.6, and 2.7. 2.5 you started working on the other day. Infinite limits. 2.6 is continuity, and 2.7 is the start of derivatives. Right now, I don't foresee us having a test over 2.5, 2.6, 2.7. Okay, these sections are going to kind of lead themselves more to just discussions and kind of exposure more than holding you responsible for a lot of information. And we'll get back rolling on that with Chapter 3. So today I want to talk about what you did for homework, 117, 5 through 21 odd. And hopefully you would admit that those, to do those with your graphing calculator seems pretty primitive. And that's kind of not what we're about. Okay? You know, granted, you started to get a feel for what some of these functions look like again. I know you've seen them before. But what I want to do is I want to take a closer look at these and decide how we might be able to glean the limit from the left and from the right to infinite discontinuity without graphing them. So I guess before I do anything on the 5 through 21 you want to take a look at? Probably got kind of real up close and personal with your graphing calculator for a while. And so, okay. So what I'm going to do is I'm just going to pick a few, and we're going to see kind of how we can justify some answers without leaning on our technology quite so hard. And then there is something outside of math that I want to talk about as well. And it's about passes and stuff, so if I forget, remind me. Okay. But weekends okay? All right. We tried a new breakfast place in Omaha this weekend, Le Peep. I have never been there before and liked it really well. It was good. Big trip to Costco. That was our big excitement for the weekend. Yeah, there's some. Yeah, we were there a little early. They were just setting up, and there was even like kids waiting around. And the lady said, 5 minutes, you can come back. And they're like, okay. And they went and checked out. It's probably another free sample situation. Okay. So 2.5, we're just going to take a look at a couple of these and see if we can figure these out without our graphing calculator. So let's go, what the heck, let's do number 5. Actually, you didn't, yeah, you had to do number 5. Limit x approaches negative 8 from the right of 2x over x plus 8. Okay. Well, we could throw a ton of theory at you on this, or we could just kind of just go, what do we think? Any ideas? Well, first of all, do you guys look at this and see it's going to be an infinite discontinuity of some sort? Why? Because what?
Like, wouldn't there be an asymptote?
There would be an asymptote. Why?
Because on the bottom, it'll lose 1.
Yeah, on the bottom, there would be an asymptote right here at negative 8, because if I plug in negative 8, it would give me 0, and then I have something divided by 0. And then we have this thing that we need to understand, that if I would, well, first of all, if I would try and plug this in, just negative 8 itself, I would get negative 16 over 0. Is that indeterminate form? Actually, indeterminate form is 0 over 0. Okay? This right here is a form that we go, something's happening. So then we can't divide by 0. We know that. So let's back away from negative 8. As I back away from negative 8, this is getting closer to 0, and that's getting closer to negative 16. The only problem is this bottom could be getting closer to 0 from the positive or negative side. It could be getting closer, like negative 1 or negative 0.1 or positive 0.1. It depends upon what's going on. So this general idea, I'm not going to graph it, terribly accurate. My guess is going to look something like this. Actually, 0. Anyway, no, this is not right, is it? Let's think about this. Okay. Let's talk about rational functions. I think this is graphed wrong. But how do I know it's going to have a horizontal asymptote at 2? Look at the equation. How do I know it's going to have a horizontal asymptote at 2? The top and the bottom combined. If we take a look like we talked about the other day, our most powerful terms on top and bottom, we've got 2x to the first and x to the first, and it's going to be a battle of those two, so it's going to approach 2 as x gets really huge. Okay? And it might be this, might be that. I think I might have it graphed wrong, so I'm just going to do a couple things, even though we won't have to do this every time. So don't even write this down. Let's just talk, okay? So if I look at my y-intercept, okay, my y-intercept is what I get when I plug in 0 for x. So I get 2 times 0, 0 plus 8 equals 0. So my y-intercept is actually 0. My graph is wrong, and I saw that as soon as I sketched it. Okay, it is going to approach my 2. Let's figure out, well, my x-intercept is going to be the same thing, because if I take this and set it equal to 0, how do we make a fraction 0? Do we look at the top or the bottom if we're wanting to make that fraction 0? The top. We take a look at the top. So how would I make the top 0? It's going to be 0 again. So in this one, we have something that actually looks like this. Okay. So the red is right. Okay. And that still doesn't feel right. I'm glad I'm recording this and putting this on the internet for everybody to see. Okay? Do me a favor, graph this, and let's see if we can figure out where I might be. Because it's got this, it's got that. It could cross this asymptote, but I don't think it does. Yeah, I think this is right. Does it look about right? Good. I doubted myself for a second. Okay. Okay. So it's going to look like this. You don't have to graph it every time, but let's really focus on as it approaches negative 8 from the positive. So if I take a look at 2x over x plus 8, okay, as it approaches negative 8 from the positive side. So the top we know, it's getting closer to negative 16. The bottom is getting closer to 0, but what's true about it? Because if I'm plugging in things like negative 7.9, what's true about the bottom? It's going to be positive. Okay? So what we've got to think about is what's going to happen to this when I'm around 8, or when I'm around negative 8, and what's going to happen to this when I'm around negative 8. So this one, regardless, we can plug it in and get negative 16, but this, when I'm coming from the right, it's going to approach 0 in a positive fashion. So then what I've got is negative 16 over something really super small, but positive. So what kind of number do I get when I have the top being negative 16 and the bottom being a really super small positive? A negative. What kind of negative? A what? Infinity. Yeah. Because I might have like negative 16, about that, divided by 0.000001, and that's going to give me negative 16,000 or whatever the case may be, which is going to be getting closer to negative infinity. So here's my point. We could just kind of look and see the behavior of this. Is it going to be positive? Is it going to be negative? And in the top, is it going to be positive or negative? And kind of see what's going to happen. Let's try a different one. Let's just go 9. Okay. So on this one, obviously the top's just getting closer to 2. Here we're getting closer to 0 from the positive side. So is the bottom going to be positive or negative? Positive. It's going to be positive, but really close to 0. So this is approaching 0 from the positive direction. So 2 divided by a really super small positive is infinity. Positive infinity. So we can just take a look at if it's getting closer to 0 from the positive side or from the negative side. That'll kind of tell us what the split's going to be and how it's going to behave. Let's do one that's a little bit more of a challenge. Okay. Well, they don't really have one that's a little bit more of a challenge. Let's do this one. Let's zoom in. You guys haven't done this one yet, haven't seen a graph for it. Let's do 18. What might be helpful on 18 is to factor this. Okay? So let's talk about what's going to happen at each one of these. As x approaches 1 from the positive side. Okay? Well, let's go ahead and zoom out just a little bit. So let's do A. What's the top getting closer to? 1. What's this part getting closer to? 2. What's this part getting closer to? 0, but is it positive or negative? Okay, why? Well, from the positive side, this is like 1.01. If I take 1.01 minus 1, this is getting closer to 0 from a positive. And it might help if I zoom so you can see it. I'm trying to get there. You can see it. So what do we have? We still have 1. This 2 doesn't really make a whole lot of difference. It's just getting closer to 0. So 1 divided by 0.0000. This is still going to be, what do you think for an answer? Positive infinity. Good. Okay. Let's talk about B. I'm going to go ahead and zoom out even more. B. 1 from the left. Well, let's take a look at it. The top getting closer to 1. This part getting closer to 2. This part getting closer to 0 from the left. It's going to be negative. So then what do we get for an answer? Negative infinity. Okay. Let's do C. Approaches negative 1 from the right. Well, those do the same thing. On the top. Negative 1. Okay. And then, so negative 1. We got to keep in mind we're talking negative 1 now. What's this one going to be? 0, but positive or negative? Positive. Yeah, because think about numbers, specific numbers. Negative 0.9. That's on the right of negative 1. So negative 0.9. This is going to be 0, but from the positive side. And then this one right here, negative 2. So then let's take a look at the whole thing. We have a negative divided by a negative times a positive. So what do we get? positive infinity. Okay? D. Okay, negative 1 from the left. Top.
Negative 1.
Negative 1. This part here.
0 from the negative.
0 from the left. It's negative. Okay? And then this part here.
Negative 2.
Negative 2. So I got a negative divided by a negative times a negative, and that gives all total gives me a
Negative.
negative. So it's negative infinity. Okay? But let's take a break here just a little bit. Why is it infinity rather than like negative 1/2 or something? Because what? Because the graph keeps going down?
Yeah.
Why does the graph keep going down?
Because it's a whole asymptote.
Because it's an asymptote. Okay, that's good. And if we look at it from a numerical value, why does the number keep going down? Because this one right here is so incredibly small that this basically wipes out the bottom, and the bottom is getting closer and closer and closer and closer to 0. And negative 1, even though negative 1 is a really small number, we have negative 1 divided by 0, or something really close to 0, so it's going to be an infinity of some sort. Okay? Is that kind of starting to hit home for you? Okay? So here's what I want you to do. Why don't you guys try 20 real quick? Okay, I've got it right here, so you don't necessarily have to have yours open. Well, my alpha, I zoomed in on the right one. I'm going to go ahead and factor it first for myself. Let's kind of stick somewhat together. Let's do A. What do you think for A? I'll give you 30 seconds to process here. So our answer is either going to be positive infinity or negative infinity. It's got a discontinuity, infinite discontinuity at negative 2. Okay. Do you have an opinion? Positive? Positive? Okay. Do you think positive too? Oh, so you think a negative? Hey, you got a 50-50 shot. Okay. So let's take a look at it. Let's take a look at it. So on this next part here, I'm going to try and sandwich this in so you guys can still see it. So if I think negative 2, this part's going to be a negative. This is going to be a negative. This is going to be just 2, which is still just a positive. And then I've got x plus 2 from the positive side. Negative 2 from the positive. This will be a positive. So positive or negative infinity? Positive.
I had it written down.
Okay? Okay. It's okay to be wrong, even if you're wrong. Okay? B. Well, B, there's only going to be one part that's going to change, right? That's the bottom. The bottom's going to be now negative. It's on the other side of that. I could go down this whole rabbit hole of sign changes, and when we have sign changes, when we don't, da-da-da-da-da-da-da. But on this case, what do you think it's going to be? The only thing it's going to change is still negative. That's still negative. This is 2, and this is now going to be negative. So the answer would be negative infinity. Okay? Ooh. C. This is interesting. This is going to make you think. If you get this one right, then it lets me know that you're really paying attention to what's going on. Is this even an infinite discontinuity? There's no asymptote here at 1. Okay? Because we have x plus 2, that's the only infinite discontinuity. The thing that's happening at 1 is different. Okay? So anybody want to volunteer their answer for C? Yeah. 0? I see one kind of somewhat confident nod. I see some uncertain looks from the crowd. I see some yawns that are way too big to, I don't know, maybe we need some caffeine or something. I'm not going to mention who. Okay? But it's 0. Why is it 0? Because let's take a look at each individual part. As I go from 1 from the positive, this is getting closer to 2. This is getting closer to 0, 2, and that's getting closer to 3. So I have 1 times 0 over 2 times 3. It's getting closer to 0. Okay? And actually, this one, even from the left, it would be the same thing. Because when we're looking at 0 on the top, it doesn't matter whether it's positive or negative. We're just getting closer to 0. This is going back to the old one of if you can plug in 1 and it doesn't give us an indeterminate form or 0 on the bottom, it just gives us our limit. Okay? Okay, D. Do D. And Willa can't answer this one, so somebody else is going to have to type up on this one. Your yawns are contagious, Leah.
Someone started it.
Somebody else started it?
Yeah.
Okay.
Because I don't feel tired.
Okay, good. Yawns aren't always from tired. Sometimes it's anxiety. Sometimes it's...
I always yawn when I'm out of breath.
When you what?
I'm out of breath.
When you're out of breath? Yep. This is where we need whiteboards and stuff. Kat, what do you think?
Negative 1/4.
Negative 1/4? I see a nod. I see a couple other nods. It is negative 1/4. This is one of the only time we've got to think about an infinite discontinuity is when the bottom 0. Otherwise, plug it in. So we get 1 times negative 1 over 2 times 2, which is negative 1/4. Okay? Don't cry over a spilled Fruit Loop.
I still don't want it.
Well, the question is now, are you still going to eat it or not? Why not?
If no one else saw it, I would eat
Okay. Okay, doke. Let's try a couple other things from this one. You know what? Let's do this. Grab some whiteboards. We haven't done that in here yet, have we? We did once? Okay. Grab whiteboards. We're going to try and draw a few things.
I thought you were coming over like, oh no.
Okay. I wish I could split screen this. I wonder if I can somehow. Okay. So what I want to take a look at here is just, this is just stuff getting more comfortable with various expressions here. We're going to try and draw one for 39. Okay? So I'll leave this up here, and you can go ahead and let's just try and draw this. What does it mean if f of 0 is 0?
When you plug 0 into the function, it's 0.
When you plug 0 and you get 0. So your point is 0, 0. Okay? So first thing they're giving us 1, 2, 3 different point values. And they're telling us when it gets to negative infinity, we're approaching negative 1. And we're approaching positive infinity, it's approaching positive 1. Go, draw it. Do you think there's only one answer for this? No, your graphs might look a little different than somebody else's, so that's all right.
Wait, is one the Y?
That's what my.
I know.
But then it says if you go to negative infinity or negative.
I think this one can be done with a continuous graph.
Wait, sorry, this.
So it's like. So much what?
Wait, I'm so
Oh,
confused.
okay. Okay, so, but you got to make sure that it's approaching -1 and approaching +1.
Yeah, I just don't got my lines. It's a little close to 0.
You just don't got your lines.
It's a little close to 0.
Okay, got it. Okay.
A little.
So you could, hers has an infinite discontinuity. It doesn't have, what did you do for 0 though?
Yeah, because
Oh, you just put a point there? Okay. You're just being a rebel. You're just like, I'm going to do whatever I want, and if I want this to be that, I'll. I'd say the problem with that is you've got an infinite Okay, which that's a function, and that's okay. That's okay. But I think we can do it being continuous.
Yeah.
Willa, yours does, I think both of your, let's see.
I don't think I did mine right.
Well, can you hold it up for me so I can see the orientation? Okay, that one's approaching infinity. It's not approaching 1 and -1. Yours is approaching infinity, not 1 and -1. So basically, I'm glad we're doing this. This is great. Okay?
Oh yeah, Leo's got it. Leo's got it
It doesn't
right.
make sense because you can't get it to negative 1 if you're trying to.
That's what I was going to do. Then the points are just hanging out on the wall.
Which is up on that one? Haley, which direction is up? Hold it. There you go. Perfect.
Yeah.
Okay?
She was like,
Okay? But I think it needs to show that you're coming back down a little bit. Okay? So let me go ahead and get this out of the way. So we've got this point here. You know, we've got basically all three of these points, but it has to approach 1 as it's going to positive infinity, and -1 is approaching negative infinity. So can lines cross asymptotes? Yes, they can, especially horizontal asymptotes. Horizontal is just what it's doing towards the edge. So I'm going to switch colors because I can. Okay? So this one makes me think of this. But then I'm going to come up and pick up that point, come down, pick up this point, and then do something like that. Okay? That's what that one made me think of. Does it have all the points on it? Yes. Because remember, this part it says limit as x approaches infinity of f of x is 1. Okay? So it's getting closer and closer and closer to 1. Okay. Let's try 40. Where am I at here? Okay, I'm even in the wrong section here. F of 0 is 0. The limit as it approaches either positive or negative infinity. Remember, another name for this is end behavior. Our end behavior is 0. As it approaches 0 from the right is 2. As it approaches 0 from the left is -2. So it's not an infinite discontinuity. Okay, f of 0, 0. So it gives you that point. So this one, I don't think we have any choice but to do a discontinuity. But your end behavior is not right. You don't have this part. You don't have this part. As x approaches either positive or negative infinity, so when I'm plugging in 100, my answer is really close to 0. Right now, your answer is really close to 1 and -1.
oh,
When I plug in 100 or -100, your end behavior,
is it that?
something like that would be fine.
Oh,
Yeah.
Oh, so do like this.
what do you mean?
It'd be like this. It like comes out and comes up. Oh,
There you
That
go.
was approaching 2.
But it is approaching
Oh.
2, because you see.
Yeah. Sure.
Okay. Good. I'm glad we're doing this. I wasn't quite sure if I wanted to do this or not. Okay. The thing. Where am I at here? Hello. Right here. Okay. The only thing I should probably do right now, it may not be a function, so I should probably do this. Just to clarify that I don't have 3 points above each other. In other words, getting 3 different answers when I plug in 0. Okay? These are kind of interesting. I like them. Let's go 41. Okay. F of 0 is 0. The limit of fx as we're approaching positive or negative infinity is 0, so its end behavior is 0 on both sides. Ooh, this one's kind of funky. This one's got a ton of different things. I like this one.
I'm going to do this. I don't think that's really fun. Jesus Christ.
Draw your asymptotes. This one does have asymptotes. Draw your asymptotes, and that'll help you. It's got an asymptote, a vertical asymptote at 1 and -1.
Oh, one thing I know what it is. Wait.
We are waiting.
Oh wait, there's no way. Oh, I didn't even see the.
Yeah, there's another row. There's another row.
I didn't see that.
Yes, there's another row. So don't forget that second row.
So there's the acid.
Let's see. Can I see it?
Wait.
It might be.
Oh, that's.
Wait, let me see.
I just.
Okay, but let's check some things. Let's check some things. Here it says, as I'm approaching one from the left, it's positive infinity. 1 from the left, it's positive infinity.
So wait, so then it would be going this way.
I'm not sure.
It would be going this way then, wouldn't it?
Okay,
Wait,
okay.
No, I'm so confused.
Okay. The thing that you seem to be missing is this part right here. This is end behavior. So when I plug in huge numbers, it's got to be getting closer to 0. So at the very outsides of my graph, it's hugging up against my x-axis.
Oh.
Okay, I'm going to give you a strategy. Oh,
No, never mind. Keep going. I thought you were going to go see the answer. I was like, don't tell us.
no. I'm going to give you a strategy. Okay? Let me draw this before I remove this from you. Okay. Let me steal this from you for just a second. I would, in some way, shape, or form, just use arrows for a reminder as to what's going on. I'm just going to do one of these, and you guys will do the rest. It says approaching 1 from the left is infinity. So as it approaches 1 from the left, it's infinity.
I got it.
So use little arrows like this, get all your behavior done, and then figure out how you connect those when you're done.
Wouldn't it be this way?
Okay? Now let me go ahead and show you this again.
1 from the right is negative.
Don't erase it yet? Okay, got it.
Wouldn't it be this way?
Okay, so let me see what some of you guys have.
You have to go down to a negative.
Okay.
What do you have to change up stronger?
I don't know if it's right yet. I feel good about it.
-1.
This is where
To go from
I wish I could do some things on the board and show on the board
yes,
all that good
go
stuff.
negative. No, if you look at the second row. Yeah, I know, but that's from the left. That's from the left.
Oh, you know what I
And from the right.
could do? No, I can't.
No, that's the other one.
One from the right is
One from the right is negative. So it is negative one from the left. Yes, there you go.
It should like that.
Okay. I'm going to try and put this both on the screen, both my drawing and this. This is going to be a challenge with where it's located in the book, but we'll see what we can do. Okay. Okay. So one part at a time. You know what? I'm going to have to go above. Okay. So 0 is 0. So we've got some limit, positive, negative, infinity is 0. So it's going to be out, but I don't know whether it's above the x-axis or below the x-axis. So I'm going to hold on that. But we're just going to be approaching the x-axis. Next part, limit approaches 1 from the left. So we got to think about what's happening at 1. 1 from the left is infinity. As approaches negative 1 from the right is also infinity. Okay? So now let's go down to that. 1 from the right is negative infinity. Negative 1 from the left is negative infinity. Negative 1 from the left is negative infinity. Okay? So what we've got to do is we've got to come down and pick up this point. And then this, granted, there's some other things that could happen, but it does need to end like this. It could actually even do this. It could come up and do this. We don't know, but it's at least going to end horizontally. Okay? That was 41, right?
Yeah.
Let's do 42. F of 2 is 1, F of negative 1 is 0. I'm going to start sketching this on another piece of paper. Limit as 0. Okay, so it's going to go this way. Oh, no. Work from this. Okay, so this one's kind of funky. Okay, I'd like you to clarify your end behavior on the left side.
Oh.
Do we have end behavior on the left? Oh, yeah, we do. Oh, it's positive 1, isn't it? Okay. Okay, good. Okay, show me what you got. Everybody, show me what you got. Good, good, good. Okay. Okay, Jesus, let me see. Good, good. Okay. Okay. So I kind of messed mine up a little bit because I read it as negative 1 instead of positive 1, so I had to scribble something out. It's going to look awesome. Okay. So you can kind of see what I'm doing. I'm just putting an arrow here to remind me where it's going. From the left, it's going up. From the right, it's going down. So we're going to have to basically come up here, pick this up, here, come down here, And now we've got to go through this point, but it's going to go hug down through 0. Okay? Okay? I kind of like those. Just kind of interesting. Okay. Well, you can put your whiteboards away. I wonder if there's a problem in the bathroom in there. It's like flushing all the time.
Unless if someone's constantly in there.
Yeah, yeah. No, that's true. Okay. I'm just going to give you guys just a couple things to think about overnight. Page 118. I want you to try and write it. It says find a function that satisfies the given conditions in sketch's graph. So I want you to find an equation for which this is the graph. Okay? Let's go 43 through 45 all. Okay? And tomorrow we're just going to talk about continuity. I'm going to have you take a look at this. There you go. I just want your gut feeling on the 1 through 4. We'll define that a little bit better tomorrow.